Okay, good morning, everyone. So now we can discuss the remaining questions. Okay. So we will start with question number 9. Is it clear, children? Yes or no? Okay. So question number 9. Complete hydrolysis of XCF6 gives option A, XCOF4, option B, XCO3, option C, XeO2F2, option D, XeOF2. Complete hydrolysis of XEF6 gives. What will be the answer? It's a direct question from your textbook. What will be the product formed on complete hydrolysis of XCF6? Page number 210.
XCO3.
Yeah, XeO3. Here you can see the page number 210. There is one chemical reaction. XCF6 plus H2O. The complete hydrolysis XCF6 plus H2O. It will gives XCO3, XC, HF, and 3O2. Right? There will be two types of reaction there: complete hydrolysis and partial hydrolysis. First set of reaction, that is complete hydrolysis. So the hydrolysis of XCF4, it will give XeO3. Option B, XeO3. Clear, children? Yes. Aditya, can you read question number 10?
Yes, ma'am. When Cl2 gas react with hot and concentrated sodium hydroxide solution, the oxidation number of chlorine changes from option A 0 to +1 and 0 to -5, option B 0 to -1 and 0 to +5, option C 0 to -1 and 0 to +3, option D 0 to +1 and 0 to -3.
Okay. Here the question number 10. When Cl2 gas reacts with hot and concentrated sodium hydroxide solution, what will be the change of oxidation number of chlorine? Okay. Here the reaction that in page number 203. 203. Hot and concentrated sodium hydroxide, it will react with chlorine to form sodium chloride, then sodium hypochlorite and water molecule. So the chemical reaction is this: NaOH plus Cl2, it will gives NaCl plus NaClO3 plus H2O. Okay, so this is the chemical reaction of chlorine react with hot and concentrated sodium hydroxide. And in this question, you can see that this chlorine is dissociated into two types of compounds, NaCl and NaClO3. So there will be two oxidation states in the product side. Okay. In the reactant side, only one chlorine molecule, but it is dissociated to two types of molecules, NaCl and NaClO3. So there will be two types of oxidation state. So can you tell me, children, what will be the oxidation state of chlorine in reactant side? Reactant side. Vidur, in the Cl2, what will be the oxidation state of chlorine?
Minus.
As a molecule, what will be the oxidation state? Cl2, it's a molecule, right? So the sum of the all oxidation state of a molecule, that will be equal to 0, isn't it? We are considering the sum of the oxidation state of all atoms in a molecule as 0. Here it is chlorine molecule, so the oxidation state is 0. Clear? Is clear, children? Gauri, any doubt? No. In the case of each molecule, when we are taking this NaOH together, their oxidation state will be 0. Okay, because the sum of the oxidation state of all the elements in a molecule, that is equal to 0. Here the chlorine exists as a molecule, so the oxidation state of chlorine is 0 itself. There will be separate oxidation state for each atom in a molecule, but altogether its oxidation state is 0. In the case of chlorine, it is existing as a molecule, so we will consider its oxidation state as 0. Clear? So in the reactant side, the oxidation state of chlorine is 0. Then we are moving to the product side, that is NaCl. In NaCl, what will be the oxidation state of chlorine? Priya?
-1.
Yeah, Cl minus 1. And in the case of Na, it is plus 1. So here it is minus 1. Okay, the reactant side, its oxidation state is 0. And in NaCl, its oxidation state is minus 1. The next one is NaClO3. Okay, NaClO3. In this compound, we have to find out the oxidation state of chlorine. So we know the oxidation state of oxygen, it is minus 2, right? Minus 2. So here there are 3 oxygen atoms, minus 2 into 3. That is the oxidation state of oxygen. And we don't know the oxidation state of chlorine in this molecule, so we will consider it as X. What about the oxidation state of sodium? Sodium. This group 1 metal, right? So what will be their common oxidation state? Group 1, 1. Okay, so plus 1. So all together it will be equal to 0. 1 is the oxidation state of sodium. X is taken as the oxidation state of chlorine because we don't know the oxidation state of chlorine. Using this equation, we will find out the oxidation state of chlorine. Next one about oxygen, their general oxidation state is minus 2 for 1 oxygen atom. Here there are 3 oxygen atoms, so minus 2 into 3. And their sum is equal to 0. So 1 plus x minus 6, that is equal to 0. So x equal to 6 minus 1, that is equal to plus 5. So in this molecule, plus 5 is the oxidation state of chlorine. So what will be the answer? What change occurs to the oxidation number in chlorine in this particular reaction? Which option will be correct? Option B, right? 0 to minus 1 and plus 5. In NaCl, its oxidation state is minus 1. And in NaClO3, their oxidation state is plus 5. So you have to remember, as a molecule or as a compound, the sum of their oxidation state, it will be always equal to 0. Okay. So if it is H2 or O2, then Cl2, their oxidation state is 0 when they are existing as a molecule or atom. And in the case of different compounds, compounds means different elements combined together to form a compound, right? So in a compound, there will be separate oxidation state for each atom, but their sum is also equal to 0. That's why we are putting here 0, right? 1 plus x plus minus 2 into 3, that is equal to 0 because their sum is equal to 0. So it's clear, children? Method of finding the oxidation states. All of you, please switch on your videos. Aditya, Anna, Nandana, Naurin, Punya, Adul, Shivani, Nia, Aryan, Srihari, Anthony, Malavika, Meenakshi, Evelyn, Nevin, all of you. Okay, next question number 11. The oxy acid of sulfur that contains a lone pair of electrons on sulfur. The oxy acid or oxo acid. Okay. The oxo acid of sulfur that contains a lone pair of electrons on sulfur is option A, sulfurous acid, option B, sulfuric acid, option C, peroxo disulfuric acid, option D, pyrosulfuric acid. The structures of these different types of oxosulfuric acid, that is in page number 194. So you look at the different structures and tell me among this different option, which one has lone pair of electrons on sulfur? Question 2, Emmanuel, you can just tell me. In page number 194, there are the different structures of oxoacids of sulfur. And among this different examples, which one has a lone pair of electron on sulfur atom?
Sulfurous acid.
Sulfurous acid. Option A, sulfurous acid. And its chemical formula is H2SO3. H2SO3, that is sulfurous acid. Then question number 12. Acidity of diprotic acids in aqueous solution increases in the order. Acidity of diprotic acids in aqueous solution increases in the order. Option A, H2S is less than H2SC is less than H2TE. Option B, H2SC is less than H2S is less than H2TE. Option C, H2TE is less than H2S is less than H2SC. Then option D, H2SC is less than H2TE is less than H2S. What will be the correct increasing order of their acidity? That's in page number 188 under the heading reactivity with hydrogen. Page number 188 under the heading reactivity with hydrogen. Here you can see one sentence. The second sentence in the heading reactivity with hydrogen, their acidic character increases from H2O to H2TE. So what will be the order? Nandana, can you tell me what is the order?
H2S less than H2SC less than H2TE.
Option A, right?
Yes, ma'am.
Okay. So here the acidic character, it will increases from H2O to H2T. So this will be the order. H2S, it is less than H2SC, it is less than H2TE. Have you completed this question, children? Then next we are moving to question number 13. Which of the following compound contains S double bond O and S double bond S bonds? Okay. Option A, sulfuric acid. Option B, thiosulfuric acid. Option C, sulfurous acid. And option D, thiosulfurous acid. So in your textbook, only a few structures are given in page number 194. And in the structures, there will be no S double bond O and S double bond S bonds. Only S double bond O bonds. Okay. So here the correct answer is thiosulfuric acid. Okay. Thiosulfuric acid. And the chemical formula is H2S2O3. H2S2O3. The name of this compound, that means the chemical formula is given here. Sulfur forms a number of oxo acids such as H2SO3, H2S2O3, H2S2O4, H2S2O5, H2XX06, like that. Okay. So among these different compounds, H2S2O3, that is known as thiosulfuric acid, it has both S double bond O and S double bond S bonds. Thiosulfuric acid. Punya, can you read next question? 14th one.
Yes, ma'am.
Hmm.
Which of the following is neutral
Oxide.
oxide of nitrogen?
Which of the
N2O,
following is a neutral oxide of nitrogen? Okay, then read the options.
N2O, N2O5, NO2, N2O4.
Okay. Option A, N2O. Option B, N2O5. Option C, NO2. Option D, N2O4. There will be a table in page number 177. We already revised this portion. Then do you remember which one is the neutral oxide?
N2O.
Yeah, N2O. Page number 177. Okay. There is a table. N2O and NO, they are neutral. Then remaining nitrogen oxides, they are acidic in nature. Okay. Then question number 15. Evelyn, can you read question number 15?
Which one has the highest boiling point? Kr, Xe, He, and Ne.
Okay. Which one has the highest boiling point? A, Kr, B, Xe, C, He, D, Ne. So that will be among noble gases. Which one has the highest boiling point? Which one?
Xenon.
Yeah, xenon, Xe. That is in page number 208. Okay, 208. There is a table with its values of boiling point. Table 7.12. Their boiling point will increases from top to bottom in a periodic table. Okay, helium, neon, argon, xenon, like that. We can just write here the boiling point increases from top to bottom in a group. Now, Rin, can you read question number 16?
The correct order of thermal stability of hydrogen halides is A, Hi greater than HBr greater than HCl greater than HF, B, HF greater than HCl greater than HBr greater than Hi, C, HCl less than HF less than HBr less than Hi, D, Hi greater than HCl greater than HF greater than HBr.
Okay. So this one in page number 201. The correct order of thermal stability of hydrogen halides. Page number 201 under the heading reactivity towards halogens. Reactivity towards halogens. So Navrin, can you tell me what will be the order?
B.
Option B. Okay. HF, it is greater than HCl, it is greater than HBr, it is greater than HI. Here you can see the sentence, the stability of these halides decreases down the group due to decrease in bond dissociation enthalpy in the order. HF, HCl, HBr, HI. That's a decreasing order. Option B. Srihari, can you read question number 17?
Among the following, which is the strongest oxidizing agent?
Options.
Br2, I2, Cl2, and F2.
Among the following, which is the strongest oxidizing agent? Option A, Br2, option B, I2, option C, Cl2, option D, F2. Which one is the strongest oxidizing agent? Can you tell me? It's in page number 200. 200. Which one is the strongest oxidizing agent?
F2.
Yeah, it's fluorine. Option D, F2. Here you can see in the third paragraph, second line, F2 is the strongest oxidizing halogen and it oxidizes other halide ions in solution or even in the solid phase. And this oxidizing nature that will be decreases from top to bottom in a group. Okay. So F2 is the strongest oxidizing agent. Then question number 18. Which among the following is the most reactive? Which among the following is the most reactive? Option A, I2. Option B, ICl. Option C, Cl2. Option D, Br2. Which among the following is the most reactive? Meenakshi, can you tell me which among the following is the most reactive? Anyone?
Chlorine.
Is it chlorine? Which one is the odd among the following? Odd one?
ICl.
ICl, right? Here the bond between this iodine and chlorine, it is weaker. Okay, so it will be very easy to break this bond and involved in chemical reactions. Okay, so option B is the correct answer. Option B. You can write here. Yeah.
Is it there in the text?
I think there is no proper sentence there in the textbook. You can write the reason here. Interhalogen compounds. Interhalogen compounds are more reactive because of weak bond between a similar atom. Between dissimilar atom. atom or atoms. Than between similar atoms. The case of other options, the same atoms combine together to form a molecule, right? But in the case of B, that is an interhalogen compound. So they are more reactive because the bond between iodine and chlorine, they are very much weaker. That's the reason. Okay. Aryan, can you read question number 19?
Pure nitrogen gas is obtained from
Hmm.
A NH3 plus NaNO2, B NH4Cl plus NaNO2, C N2O plus Cu, D NH4 2 Cr2O7.
Yeah. Pure nitrogen gas is obtained from. This question we already discussed the beginning of this chapter itself. So you can tell me which one is the correct answer. Aryan?
NH3 plus NaNO2.
Isn't it? NH3 plus NaNO2. Please look at the page number 174. 174. Which are the three methods given here for the preparation of dinitrogen? First one is NH4Cl plus NaNO2 giving N2 plus 2H2O plus NaCl. And in this method, small amount of NO and HNO3 are also formed, but these impurities can be removed by passing through sulfuric acid. Okay. So this one is one of the method for the preparation of dinitrogen. And the next method is the decomposition, thermal decomposition of ammonium dichromate. So this one is also comes under the preparation. Okay. And the third method that is not mentioned in the options, but that is the very pure nitrogen obtaining method. Okay, that is from barium acide. But here in the option, that barium acide that is not given. So we will go with option B. Because here the impurities produced can be removed by passing it through H2SO4, sulfuric acid. Okay,
Ma'am,
1 minute. Yeah, Punya, ask me.
ma'am, in ammonium dichromate, we can't remove the impurities.
There is no such method mentioned here to remove the impurities.
Okay, ma'am.
Okay, so the pure form of nitrogen can be obtained from NH4Cl plus NaNO2. Along with dinitrogen, the sodium chloride is also produced. In this ammonium dichromate, chromium oxide and water molecule also produced along with nitrogen. So it is not removed. So the pure form, very pure form of nitrogen is from barium acide. If that option is not there, you can go with ammonium chloride and sodium nitrate. Okay. Adul, can you read question number 20?
The oxo acid of halogen having maximum acidic character is HClO4, HClO3, HClO2, HClO.
Okay. The oxo acid of halogen having maximum acidic character. Anyone? Any idea about the acidic character, maximum acidic character among this oxo acids of halogen atom? This oxo acids of halogen atom that is in page number 205. 205. HClO4, HClO3, HClO2, and HClO. But here it is not mentioned about their acidic character. So here the correct answer is option A. And the reason is that when oxidation state increases, their acidic character also increases. Okay. When oxidation state increases, acidic character also increases. So we can just look at the oxidation state of chlorine in these compounds. First one, HClO4. Hydrogen, the oxidation state is 1. And we don't know the oxidation state of chlorine. So we are taking it as X. Then in the case of oxygen, it will be 8, right? Sorry, it is -8. -8. 4 into -2, that is -8. That is equal to 0. So X equal to 8 minus 1. That is equal to 7, right? Plus 7, that's oxidation state of chlorine in HClO4. Then next we are going with HClO3. Here it is 1 plus X minus 6, that is equal to 0. So X equal to 6 minus 1, that is equal to plus 5. Here the oxidation state is plus 5. The next one is HClO2. Here it is 1 plus X minus 4, that is equal to 0. So X equal to 4 minus 1, that is equal to plus 3, right? And the last one, that is HClO. 1 plus X minus 2, that is equal to 0. So X equal to 2 minus 1, that is equal to 1. So among this different oxidation state, HClO4 that has the maximum oxidation state. So when the oxidation state increases, their acidic character also increases. So due to this reason, option A is the oxoacid of halogen having maximum acidic character. Shall I move to next question? Anthony, can you read question number 21?
Which one of the following
Order.
following order is correct for the bond discussion enthalpy of halogen molecule?
Bond association enthalpy of halogen molecules. Options?
Br2
Greater than?
Br2 greater than I2 greater than F2 greater than Cl2 and Bf2 greater than Cl2 greater than Br2 greater than I2 C I2 greater than Br2 greater than Cl2 greater than F2 D Cl2 greater than Br2 greater than F2 greater than I2.
Okay. So these are the options. Which one of the following order is the correct for the bond dissociation enthalpy of halogen molecules? What is bond dissociation enthalpy? the energy required to break the bond between the atoms. Okay. So here, which one of the following order is the correct one for the bond dissociation enthalpy of halogen molecules? It's in page number 199. 199. In the heading physical properties in the second paragraph, you can see. So please read this portion and tell me which one will be the correct answer or correct order.
D.
Option D, right? Because in the case of chlorine, bromine and iodine, chlorine it is greater than bromine, it is greater than iodine. And fluorine, it is an exception. There will be a smaller enthalpy of dissociation for fluorine. Okay. And it is greater than iodine. That's why option D. Bond dissociation enthalpies from chlorine onwards show the expected trend. Chlorine, chlorine, it is greater than bromine, bromine, it is greater than iodine, iodine. And in the case of fluorine, there will be a smaller enthalpy of dissociation due to the lone pair in F2 molecules. So option D, that is the correct answer. This is clear, children? Shall I move to next question?
Yes, ma'am.
Okay. All of you, please switch on your videos. Question number 22. Among the trihalides of nitrogen, which one is least basic? Okay, among the trihalides of nitrogen, which one is least basic? Option A, Ni3, option B, NBr3, option C, NCl3, and option D, NF3. Among the trihalides of nitrogen, which one is least basic? Which one is the correct answer, children? Any idea?
NH3.
NF3. What's the reason? NF3. Gauri? Just 1 minute, children. Yes, in page number 174, you can see that all the trihalides of these elements except those of nitrogen are stable. In the case of nitrogen, only NF3 is known to be stable. Okay, so this has more basic property compared to other forms. All the trihalides of these elements except those of nitrogen are stable. Okay, so here among these different halogens, the correct reason of this question that's not given here. Okay, I will check this question and inform you in the next class. Okay, so the correct option is D. I will tell you the reason in the next class. Now it's time, right? So we can discuss the remaining question and the question paper in the next class. I think most of you have made mistakes in the assertion reasoning section. Is this difficult for you, children? Yes, right? Okay, so we can practice more problems related to assertion reasoning. Okay. Okay, then see you in the next class. Let me take your attendance. Just wait. Okay, then thank you, everyone. See you in the next class. Bye. Have a nice day.